the new one that I've done.
This is already here?
Yeah, if you hit. In this lesson, we'll be talking about variables and expressions. Our guiding question, what you want to keep in mind while we're going through this, is what is the difference between an algebraic expression and a numerical expression? Our essential understanding is that algebra uses symbols to represent quantities that are unknown or that vary. And you can represent mathematical phrases and real-world relationships using symbols and operations. It's important that you know the definition behind some key terms. Variable is a symbol, which will usually be a letter, that's going to represent the value of a variable quantity. An algebraic expression is a mathematical phrase that includes one or more variables. A numerical expression is a mathematical phrase involving numbers and operation symbols. If you look at the top here, there's a link for an additional video about variables and expressions. Should you have any other questions about those definitions that we talked about on the previous slide, on your note sheet, you could click this link and it will give you some more explanation if you need it. Now we're going to go on and look at a few examples of how we can write an algebraic expression. If we look here at problem 1, they give us the word phrase 32 more than a number n. They show a model, and then they show us how it's written as an expression, n plus 32. 58 less a number n would be written as 58 minus n. If instead of 58 less a number n, if I had 58 less than, then I would have n minus 58. N minus 58. That word than being the difference in 58 less than and 58 less the number. So make sure you pay attention to that. I would now like for you to try the got it. What is an algebraic expression for 18 more than a number n? And you should have 18 more than a number n. You could have n plus 18, or you could have 18 plus n. Now we have problem 2, writing expressions with multiplication and division. We have the word phrase 8 times a number n. They show us as a model, and then we get to our expression. Can be written any of those ways. In Algebra 1 in high school, the 8 with the n beside it is the preferable way to write it. Example B, the quotient of a number n and 5. Quotient means division. So then I could write either of these two ways for the expression. Again, being as we're in high school now, writing them as a fraction is the preferable way to write a division problem. Now I would like for you to look at your got it. 6 times the number n would be 6n. The quotient of 18 and a number n would be 18 divided by n. And C, do the phrases 6 less a number y and 6 less than a number y mean the same thing? We talked about that up in the previous slide. No, 6 less a number y would be 6 minus y. 6 less than a number y would be y minus 6. That than being the key word. We are now at problem 3, writing expressions with 2 operations. Example A, 3 more than twice a number x, 3 plus 2x. Nine less than the quotient of 6 and a number x would be 6 divided by x minus 9. The product of 4 and the sum of a number x and 7, whenever you have wording that says sum or difference, that means you've got to account for that sum or difference as a quantity, which means we put parentheses around it. Looking at the got it, 3a, 8 less than the product of a number x and 4. Product of a number x and 4 is 4x. 8 less than that would be minus 8. Got it B, twice the sum of a number x and 8. Sum meaning addition. So I'm going to take the quantity x plus 8 and multiply it by 2. Then the example C, the quotient of 5, which means 5 divided by the sum of 12 and a number x, which would be 12 plus x. Looking at a problem 4, using words for an expression, now they give us the expression and they want us to write out the words. There will be more than one way to write word phrases for the varying expressions. If you look at the example, we had the expression 3x, and they give you 2 possible ways that that word phrase could be written. 3 times a number x, the product of 3 and a number x, or you could say 3 multiplied by x. There are varying ways to do it. On your note sheet, I want you to write word phrases for the got it problems 4A through D. If I look at this problem here, it says suppose you draw a segment from any one vertex of a regular polygon to the other vertices. A sample for a regular hexagon is shown below. Here where they have the dotted lines, they're drawing a line from one vertex to each of the other vertices. They ask us then, using the table, to write a rule for the number of non-overlapping triangles formed. If we look in the left column, they tell us the number of sides of the polygon. And that we are calling the variable n. The resulting number of triangles is what they want us to figure out. If we look there in this right side of the table, I notice that whatever number of sides of the polygon, n, I take that and I subtract 2, and that tells you how many triangles are formed. So that would be our rule. And then they ask you to write the rule in words and as an algebraic expression, which is what we just did right here. This is the algebraic expression. I would like for you to write that in words. Lastly, with this lesson, we have our lesson check. I would like for you on your note sheet to answer these lesson check questions, and then the answers can be checked in the answers in the back of your textbook. You can open it up, open up your e-text on your computer, and you can check your answers. Make sure if you have any questions that you have them ready, and we can talk about those when you're working in your groups in class.